Alright, welcome back to another video. I'll be talking about enzyme inhibitors. Before that, I'll be going over basically what happens with an enzyme substrate reaction. So let's say you have an enzyme that's kind of like shaped like this, and let's just say we have a substrate that's like shaped like that. Alright, so then during a reaction, because there's an active site here, and just assume that this can fit into that. When they come together, they're formed where now they become an enzyme substrate complex, something like this, where they come together. And then afterwards, the substrate itself doesn't change at all. But then let's just say we had new products that are, let's say, like broken off halfway in between here. So we have like these two as our product. So typically the equation is something like this, where you have your enzyme plus a substrate. It goes through the reversible reaction and it becomes a enzyme substrate complex, and this eventually leads to an enzyme plus your product. So yeah, that's kind of like the short basis of what happens when you have an enzyme with a substrate and how you can make a product that goes fast. All right, so one of the inhibitors is called a competitive inhibitor. The inhibitor directly binds to substrate. So let's just say we have a substrate that looks like this. We have, let's say, this as our substrate. This is our E for enzyme. And then we have an inhibitor. So for this competitive inhibitor, we will eventually get a reaction that will look something like this, where the inhibitor directly binds to that active site from the enzyme, which makes it difficult for the substrate to even configure with the enzyme itself. And so typically this will look something like this here, where the enzyme is directly with the inhibitor. Because the inhibitor is binded directly to the enzyme, we would have an increase in our Km, because now it's becoming more difficult for the substrate to bind to the active site of the enzyme because of our inhibitor taking that spot. Another one is called an uncompetitive inhibitor. And here this basically binds on the enzyme substrate complex. So basically here we could have our substrate binding to our enzyme along with our inhibitor just binding somewhere along the way, either be directly right here, here, or right here. But either way, whatever happens, we know that the substrate and the enzyme are binded together anyways. It is only the enzyme substrate complex that's being inhibited. And because that's being binded to that portion, we would have a decrease in our velocity maximum and a decrease in our Km, because this one just basically happens after the substrate is being binded to the enzyme, and because of that, this reduces the Vmax. Next, we have a non-competitive. All right, so this one here binds to the allosteric site, which basically just means that it's not on like the active site or with both the enzyme and substrate complex together. Since this is our inhibitor, this could just bind right here, which could cause a configuration change or whatnot. And this could happen both when both the enzyme and inhibitor are binding together, or when the enzyme is on its own. So therefore, this basically does both. And the only thing that happens here is you just get a decrease in the velocity max. All right, now I'll just show you what it looks like in the Lin-Weaver plot. This will just be our original OG. Boom. All right, so now I'll be showing you what happens in a competitive. And because, like I said, the only thing that happens for a competitive is you increase the Km and your Vmax stays the same, we could have a graph that looks something like this, where it's being pushed here on the x-axis, and that's it. So you have a new change of slope that basically, as you can see, it's an increase. So you're basically increasing your slope too. Uncompetitive, it's both your Km and Vmax that decreasing. So you could have something like this, where your original basically just shifts to the left and your slope is just the same. And in non-comp, we know that it's just a decrease in Vmax. And so your Km stays the same. We're decreasing our Vmax, so we have a higher portion here. And it could look something like this. So yeah, hopefully that was helpful.